So in this first section of Chapter 1, we're going to review some ideas from geometry. And so please take notes on what is in the green boxes. We will need those for our next class. So on a sheet of paper, write down everything you see in a green box and understand what they mean so that we can actually put them to use during our next class. Alright, so we first need to know how many degrees are in a circle. And so what that's measuring, it's actually measuring the central angle. So if you draw a circle and you start to measure as you go around, one complete revolution is 360 degrees, and that's what this diagram is saying. Okay, if we cut that in half and we only go halfway, like what we see here in the second part, we get a 180 degree angle. So an angle formed by a straight line measures 180 degrees. We also call this straight line, or the angle formed by the straight line, a straight angle. Okay, so we need to know some special relationships, and that is angles that add to 180 degrees are called supplementary. So if I have a straight angle here where I have, this is angle A and this is angle B, we say that angle A and angle B are supplementary. We also say that angle B is the supplement of angle A. And just like we have a name for angles that come together to form 180 degrees, we also have a word to describe a pair of angles that measure 90 degrees together, and those are complementary angles. So this is the notation that we use for a right angle. Right, the little box in the corner. So if I have two angles again here, angle A and angle B, I say that angle A and angle B are complementary, and that angle A is the complement of angle B. Okay, so know the measures of angles that are supplementary and complementary and be able to identify them. Moving on to additional relationships, we're going to talk about vertical angles. So vertical angles are formed by two lines that cross. Okay, and so notice here, let me get another color. One way that you could remember what vertical angles are is notice how vertical angles start with a V. So if I have this angle here that forms a V with this angle here, these two angles here are vertical angles, and they are equal. So similarly, let me take out another color, how about green? I have this angle here and this angle here. Those two angles are vertical angles. So the green angles are vertical angles, and they have the same measure. The red angles are another pair of vertical angles, and they also have the same measure. Okay. Now let's move on to the next one. If parallel lines are cut by a transversal, then alternate interior angles are equal, and also corresponding angles are equal. Okay, so there's a lot going on here. So let me start by drawing two parallel lines. And the way we're going to denote parallel lines is by putting these little arrows here. Okay. And then I'm going to cut it with a transversal. So a transversal is just another line. Okay. So I have two parallel lines cut by a transversal. And so what I want to do is I want to give you some angles here. That'll be angle A. This will be angle B. Here I have C and D and E. And I think that's enough for now. Okay, so let's pick apart these names, and let me use a red pen for alternate interior. So alternate, that just means alternate sides of the transversal, and interior meaning inside the parallel lines. Okay, and so one pair of alternate interior angles would be angle E and angle C. Both, do you see how they both form like small acute angles, right, they also make a z, right? That's how some of my previous students remembered it, is that alternate interior angles are formed by the z, okay, the inside of the z. So here we say that angle E and angle C are alternate interior. Can you see another pair of alternate interior? I think that's actually, nope, that's not it. Angle D and angle B are also alternate interior. So it's a big Z, but angle D and angle B are also alternate interior. Okay. Now let's move on to corresponding angles. And corresponding angles, let me see a different color here. How about black? With corresponding angles, those are on the same side of the transversal and the same side of the parallel lines. Let me explain. Okay, so let's take this angle A. Now there's a few angles that are that I've named that are on the same side of the transversal, right? Namely E and D. But notice here that I have this line parallel to this line, and that both the A and the D are above, right, the parallel lines. And so they look the same as well, right? So angle A and angle D are corresponding angles. And let me give you another example. I'm missing an angle over here. How about let's call this one here F. What angle corresponds to angle F? Well, we have a couple of choices. We have C and B because those are on the same side of the transversal. But notice that angle B is on the same side of the parallel line, right? This is below one of the parallel lines. This is also below one of the parallel lines. So angle F and angle B are also corresponding. Okay. Moving on to our next one. Oops. We need to talk about triangles. So, the sum of the angles in a triangle is 180 degrees. So this x plus 115 plus 25 has to add up to 180. And that way we can figure out how many degrees x is. So let's work that out. So we have 115 plus 25 plus x is equal to 180 degrees. Well, 115 and 25 is what? 140? So 140 degrees plus x equals 180 degrees. That means that x is 40 degrees, right? And so we're going to use the fact that the sum of the angles in a triangle is 180 degrees quite a bit. Okay. Now the right triangle is a special triangle where it has one right angle. Okay, and that's marked by the little square. And so from here we can still figure out x, right? Because we know that the right angle is 90 degrees. Our other angle that we're given is 34 degrees plus x is 180. So 90 plus 34 is 124 plus x is equal to 180. So I believe that x is 56 degrees. Okay. So we also need to know that the right triangle has one angle of 90 degrees. And so usually we just want to look at them and look for that right angle. And that's how we're going to know we're dealing with specifically a right triangle. Okay. Now a couple of other special triangles are what we call equilateral and isosceles. So equilateral is really special in a sense that all three sides have exactly the same length. And related to that, all three angles are also equal. So if we have three angles, we'll call them x, equal to 180 degrees, that means that each angle in an equilateral triangle is 60 degrees. Okay? Alright. Now an isosceles triangle means that two of the sides and their corresponding base angles are equivalent. Okay, so this angle here is congruent to this angle, and this side is congruent to this side, meaning that they are equal in measure. Now that we're familiar with all that vocabulary, let's take a look at the video homework. So this is a part of your homework, and what you should do is to copy the following problem and the diagram right here, and do it and submit it with your homework that's due at the beginning of the next class. So in this picture here, we have a parallelogram, basically this shape formed by two sets of parallel lines. So the ones with the two markers, that's one set of parallel lines, and then in the other direction with one marker, we have another set of parallel lines. So here we have a parallelogram, and what I'd like for you to do is to identify two pairs of alternate interior angles, two pairs of corresponding angles, and, you can't see this, but two pairs of vertical angles. And so I know that not all the angles are named, but you have enough names here that you can come up with something. Okay? And if necessary, come up with new names. Like you can name, if you want this angle right here, you can call it F if you want. But angle A is this little wedge here. Angle 1 is in this corner here. Alright, and please review this video as necessary so that you know the vocabulary that we are going to be using in the next class session.